Hi, I'm Tim Bickmore. I'm a professor in the Khoury College of Computer Sciences, and I direct the Relational Agents Lab here in the Institute for Experiential Robotics. So what drew me into robotics? I worked in the virtual agents field for about a decade before I started with robotics. So virtual agents are animated characters, and we use them to simulate face-to-face conversation the way people do. And my interest was in applying these for health counseling to make people healthier. And what I was interested with robotics is looking at the affordances of robotics. That is, what can robots do that virtual agents can't do? For example, they can be much more effective at using nonverbal behavior, like gaze behavior, to say select which person they're talking to in a multi-party conversation, if we're doing group counseling, for example. So I started this work in about 2017. And we looked at using a fur hat robot like this one for couples counseling to help couples get better at communication skills. What the field was like back then, the most commonly used robot in research was the Now robot, which was a small toy humanoid robot. The fur hat and Pepper had just come out. People were starting to look at social applications of robots. So things like how do you build trust with robots, robot personality, and other sorts of things that simulate social interaction between people. So what's fundamentally unsolved in human-robot interaction? So I'm interested in simulating human face-to-face conversation. And if you study what goes on in human face-to-face conversation, it's this very tight, synchronized dance that people perform with each other, synchronized at the millisecond level. Things like when one person gestures, the other person does a facial display, or when one person gazes in a particular way, the other person might respond with a vocal pitch. And these reactions are on the millisecond level of timing. And when you look at human-robot interaction, they're very far away from this, both in terms of response time, both because of actuators and the computation that goes behind it, but also because we can't sense all of this nonverbal behavior multimodally in the fine-grained way that people can and react to it in the same way. So human-robot interaction just looks very slow and stilted compared to what people can do. So we're still a long ways off from doing that. So one project I've been interested in most recently with human-robot interaction is looking at robots in home environments to promote health. So for example, if you're in the kitchen trying to get you to make healthier food choices, if you're on the way out the door persuading you to grab your gym bag so you do some exercise. We've been looking at a couple ways of doing this. One is with a mobile robot like Pepper that can get into place and persuade you when you arrive there, because Pepper's so slow, we have to be able to predict where you're going to be several minutes in advance so it can get into position in order to persuade you. The other thing we've been looking at doing is embedding robots in domestic environments. So for example, we put Fur Hat in a refrigerator in a home for several days to look at how it could persuade healthy snack choices when you open the refrigerator door and there's Fur Hat talking to you about your food choice. So one thing engineers don't expect is the classic user interface problem of expecting your users to know everything you do when they come to the interaction. We have to design interactions between laypersons and robots accounting for an infinite variety of linguistic backgrounds, cultural backgrounds, technical literacies, health literacies, and making sure that our systems can adequately respond and help people of these wide ranges. And often engineers forget this when they're designing and think that everybody has the same background that they do. Oh, if my research succeeds completely, in 10 years I hope we have a robot in every home helping people live healthier lives. A robot from fiction that I enjoy is Data from Star Trek, although I know it's debatable as to whether that's actually a robot or not. But I view that as sort of the end goal of human-robot interaction research, is to produce something like Data and still illuminate some of the problems that we're going to face when we get there as we approach human capabilities in the nuances of human-human interaction. One tool every robotics lab should have is a video camera, so we can record all of the crazy things that people do when they interact with our robots.